Hello again folks, and a happy new year to you all. I thought I'd start off 2018 the way I mean to go on by actually making some videos for you. I haven't made any in a couple of months, and the reasons for which were hopefully explained in my upload last night. But here we are. I thought tonight we'd take a look at this Tandy Arcade 12, or Radio Shack 12, which is a games arcade machine from, 80s, 90s, that kind of era. I actually owned this particular unit, or one of these units, when I was a child, about 11 or 12. I explained in a previous video that as a child I spent a lot of time in Tandy, buying components and bits and pieces, and I always wanted one of these, and I pestered my mum and dad for months and months and months, and they eventually bought me one for my birthday or my Christmas. I can't recall which one it was now. However, I had it about 3 days, and me being me, decided to take it apart and couldn't put it back together again, so hopefully we won't have that problem tonight. But yeah, I don't remember what the cost of this was. Probably around £15 or something at the time. Let's say sold in Tandy, probably Radio Shack in the States and other places. And yeah, just a simple games machine, a more advanced version of Simon, if you will. 12 games included. You can see the list here, and obviously it's actually written down in the top of the buttons. And yeah, just a really cheap games machine. It didn't need any TV to play it, anything like that. You just chucked the batteries in it and you took it with you in the caravan, or camping, or whatever you wanted to do. It was fairly, I wouldn't say advanced for its time, but it was a futuristic type toy, I would suggest. So yeah, that's this a backstory. I got this one off eBay for about £6, I think I paid for it, including delivery. Quite nice the fact that it's boxed at that price as well. You don't often get boxed vintage stuff for that sort of money, but it's not without its problems. It was sold as working, however, one of the lights is definitely out, the lamps is definitely blown, and I think there's a couple that are temperamental. So what we're going to do in this video is take it apart, have a look at it, try and repair it, and well, we're not going to try and repair it, we will repair it, and rather than repair it with incandescent bulbs, I'm going to retrofit LEDs to it, so it's going to make it last essentially forever, provided it's looked after. So that's what we're going to do. So I'll pause the video now. I'll take the screws out. In fact, no I won't. We'll plug it in. I don't have any C-size batteries, so what I'm going to do is just hook up to the bench power supply. So yeah, I think this was originally made in 1981. The original Tandy or Radio Shack 12 was a beige, more sort of space age looking, if that isn't space age looking enough. It was a more chunky, beige plastic. It looked like it was straight out of the space shuttle, something like that. And I think that was the original 12, or it was the original 12. But on the Wikipedia page for this, it talks about all Radio Shack products having a date code within the battery compartment, and apparently this is on every Radio Shack product. 7 is the month, so that's going to be July. The A does not mean anything, it's just purely a separator between the month and year, and the 1 is clearly the year. So it's not going to be 1981 because this is the more modern version, so this can only be 1991, I should say. So that's going to be July 91 that this was manufactured. So I'll turn this on. Now I must warn you that this is particularly loud. Now which side is the wires on? Yeah, it's this side. Oh, is that one coming off? No, still on. Check the output on, and here we go. And that didn't work. Do you know what? I think it's just got a solder tab on that side. Not to worry. I'm not going to bother editing this out, you're just going to have to put up with it, sorry. So 10 is not illuminating, as you can see there. But yeah, quite a loud machine. And what you did was you just pressed the button for whatever game you wanted, and then pressed to start. And then this is just a simple Simon. I didn't see a light, so I can only assume it's that one. And of course, if you get one wrong, yeah, you get the gist of it. Lots of different games, lots of different things you can do. What we're going to do with it is, of course, fix it. So what I'll do is I will pause the video, I'll get the screws out, and then we'll have a look. Catch you in a moment. Okay, welcome back. Right, that's all the screws out. I've had a little dig around with the multimeter just to save a bit of time. What I've done is I've probed out the bulb locations just to see what is the common side, and also what the polarity is, because of course an incandescent bulb will work regardless of polarity, whereas an LED is polarized and will need to be inserted into the correct way in order for it to function. I've also taken a look at the voltage that's been sent to whatever location to power the bulb. The bulb that is blowing, we're getting around 5.5 volts. So the LEDs I've used one of the online LED resistor calculators just to make sure that we're not going to fry the LED. The LEDs I've got are between 3.2 and 3.8, I think, volts forward voltage, and basically based on the current, etc., it's suggesting around about 120 ohm resistor. Now I have used that suggested resistor value with the LED and just powered it off the bench supply at sort of 5.5–6 volts, and I'm not happy with the brightness of them. They're being driven quite hard, so I've got 470 ohm resistors to put in place, and you know, it's a bit overkill, but at least we know the LEDs will be protected. So I think what we'll do now is actually start the repair. I'll just disconnect the power supply, and what I'm going to do is just remove these wires just to make the job a bit easier, just so we can have the bare board to work on. I have marked on the board where those go. Okay, right, let's lift out the board. Do this rather gingerly, because I think this is where it all went wrong all those years ago for me. I think I might have taken all the screws out, so there we go. Not a lot to it. What have we got there? B9112, not sure what that is. Buttons are really simple, just a sort of spring contact with a little stud on the board. Yeah, not a lot to it. Switch, some diodes. Might replace that cap as well. What value is that? 4710 volts, 47 microfarads, 10 volts. I've definitely got some of those knocking around, so I'll replace that as well, just to make sure it's all up to scratch. There's something I did notice. Let me get a pointy thing. If you look here, it looks like there's a couple of dry joints. I don't think that's affecting the bulb that's actually blowing, but something we're going to have to address as well. Okay, so looking at the actual construction of the lamps, we've got a small incandescent lamp and a plastic holder, and that's just mounted onto the board. So I think what we're going to do is we'll just desolder the bulbs, put the LED in place. Now I've got 3mm LEDs, which should work out quite nicely, providing I get the spacing correct, because we want them to protrude enough that they actually go through the hole, because I don't want it underneath and potentially flooding out the other indicators and buttons on the upper half, if that makes sense. So yeah, we'll desolder one of those and see how we're going to mount it. My intention to mount to fit the resistor is basically to cut, I mean, let me show you a good example. So this one here, for instance, my intention will be to install the LED, solder the LED in, then cut the track here, and then just tack the resistor across those two solder points. Now, of course, if we want to use an analogy, we think of a resistor as, or an electrical circuit as plumbing for a fluid. The fluid in this case is electricity. A resistor is basically a narrow pipe, and depending on how narrow the pipe is, it will resist or reduce the flow of electricity. So in a fluid term, it doesn't matter whether that's before or after a certain piece of equipment. If that narrowing or resistance is there, it doesn't matter if it's before or after, it will still reduce the flow of current. So it doesn't matter what side we put the resistor on, be it the anode or cathode, is the point I'm trying to make. Okay dokes, so yeah, we'll start by trying to take off one of these bulbs, see how easy it's going to be. Now clearly I'm not going to do the entire video with me desoldering stuff. I will just stop and get it all finished, but we'll start by taking this one off and see how well it comes off. Now I want to take care not to melt the plastic spacer or holder, and that doesn't look too bad at all actually. There we go, that came out reasonably easy. So there's a holder. I did melt it slightly. And the LEDs come out, the bulb come out reasonably easy. And let's just see how this fits in now. Do you know what? That's almost perfect. Let's compare it. Yeah, that's ideal. You can see that the LED sits slightly more higher than the old incandescent bulbs, but that's going to be perfect. I think it's not going to cause us any problems at all once it's been fitted. So yeah, let's pop that through. So on this one, the anode's at the top. So anode at the top. Anode is a longer lead, so we'll pop that through there. Like so. Pop the holder in. And just push that LED in there. Like so. Solder it up. We shall clip the leads off. Just check it now. Yeah, that doesn't look too bad at all. And now what I'll do is I'll use a sharp knife, and in this instance we don't have anywhere. Yeah, I think we'll probably go for this one here. So I'm going to cut the track here, taking care not to cut the adjacent track, otherwise we're going to have problems. And I'll just verify that that's actually cut by using the continuity on the meter. Sorry, hopefully you saw that. So the cut's just here. And we'll check for continuity. So that's definitely been cut. Yep. And then what we'll do is we'll take our resistor, tack it onto one side LED. And put it onto that side of the next bulb along. Of course, we will need to take this off. We need to take that off again when we're taking other bulbs out. But there we go. So I mean, it is a bit of a bodge, but I think what we'll do now is try and power it up and see if that LED does illuminate. So just bear with me. Okay, welcome back. Right, I had a little bit of a drama there. I won't go too much into detail, but I was a little bit lazy when I was marking down and I put the wrong polarity on here. As you can see, this side, I marked positive on here, so I went from left to right. There's positive on here, and I wrote positive there, but as you can see, the top track here goes to the lower side here, so if that's positive, it must be positive on that side. Anyway, we've got it squared away. So there is the incandescent bulb, as you can see, and if I select this one here, you can see that there's a nice warm yellow glow there. It's not been driven too hard. It's a similar brightness. It's a different colour of light, but it's a similar brightness. If I just compare that there. So I'm reasonably happy with that now. So what I'll do now is I will change the rest of the LEDs out for, change the rest of the incandescent bulbs out for LEDs, and then we'll come back and have a look at it when we're reassembling it. I'll catch you in a moment. Okay, welcome back. Right, that is the sort of mod or retrofit of the LEDs complete. I have to say this is by no means my finest work. A couple of bodges. I'll talk you through where I went wrong. If you recall, a few moments ago I said that it didn't matter which side the resistor went on the LED, and that in theory is correct. However, I was cutting certain traces and realised that the traces I was cutting was feeding the next sort of light along. So the LEDs had to actually all go on the cathode side, the negative side, for this to actually function properly. So you can see bodge there, there's a bodge there. This here, I've actually lifted the tracks off the PCB. So I've had to put a blob of solder on there and a little link wire over here just to repair that track, and more so just to give it some more sort of structural integrity, because obviously I'm not going to perform a full track repair on that, on this, you know, cheap toy, if you like. So a good blob of solder, not ideal, but it does give good structural support when used in conjunction with these standoffs. Essentially, the big blob of solder prevents it from pulling through. So if I turn it off and turn it back on, you will see that all lights or LEDs are now working, and you know, it's now ready to be reassembled. I have replaced that capacitor like I said I would. This is a 47 microfarad 10 volts. I replaced it with 47 microfarad 16 volts. It's okay to go up in voltage when replacing capacitors, but never lower. So you couldn't put, say, I don't know, a 5 volt capacitor on there. Not that you tend to get 5 volt capacitors, but it's okay to go up, but just not down. So what we'll do now is I will again pause the video, reassemble it, and we'll see what it looks like through the coloured buttons. Bear with me just a moment. Right, welcome back yet again. Right, let's have a look and see what it looks like. Fantastic. I think you'll agree that looks pretty good. Yeah, got a nice sort of star pattern, or a cross if you like. I don't recall the original incandescents doing that. Maybe it's just maybe it did, and maybe I just didn't realise. But yeah, I think that's quite a nice effect. And of course, that's it, essentially future-proof now and is preserved. These LEDs, the fact that they're being underdriven, they should last forever. We've replaced that electrolytic capacitor, so you know that's going to be good for a good few years yet. That's not going to leak potentially. So yeah, it should last indefinitely now. I don't imagine I'll be playing it every day. But there we go, that was the Radio Shack, or Tandy Arcade 12. I'm sure you'll agree, not my finest workmanship, nor my finest video. I'm a bit out of practice, as you well know. But thanks indeed for watching. Hopefully you did find it interesting. If you did find it interesting, as always, please give me the thumbs up. If you genuinely didn't like it, of course, give me the thumbs down. Any interaction on my videos is welcome. Of course, leave any comments you may have down in the thingamabob down below there. If you haven't already done so, and you'd like to do so, click on my fat head down here, and stay tuned for that competition time for 5,000 subscribers and 1 million views, which is fantastic. Yeah, as always, take care of yourselves, and all the best.